Welcome to our lecture on atomic theory. Today we're going to dive into the microscopic world to understand the very foundation of electricity. We'll explore the structure of the atom, how electrical charges work, the behavior of electron orbits, and why some materials conduct electricity better than others. Let's start with the basic building block of all matter, the atom. Every element has its own unique atom. At the center of an atom is the nucleus, which contains two types of subatomic particles, protons, which have a positive charge, and neutrons, which have no charge. Whizzing around this nucleus in specific paths, or orbits, are electrons, which carry a negative charge. The nucleus itself is always positively charged because it contains those positive protons and neutral neutrons. The number of protons is incredibly important. It's called the atomic number, and it determines exactly which element the atom is. For example, carbon always has 6 protons. Now, let's look at the electrons. While protons are heavy and firmly stuck in the nucleus, electrons are incredibly light, about 1,840 times lighter than a proton. Because they are so light and are located on the outside of the atom, they are the particles that actually move and transfer electrical energy. Normally, an atom has an equal number of protons and electrons, so their positive and negative charges cancel out, leaving the atom electrically neutral. But atoms can gain or lose electrons. When this happens, the atom is no longer neutral. It becomes what we call an ion. Since protons are tightly bound in the nucleus, it's always the electrons that are added or removed. If an atom loses an electron, it has more protons than electrons, making it a positive ion. If it gains an electron, it becomes a negative ion. This process is called ionization. The behavior of these charged particles is governed by a fundamental rule, the law of electrical charges. It's simple. Like charges repel each other, and unlike charges attract. So 2 positive protons will push away from each other, as well 2 negative electrons. But a positive proton and a negative electron will be drawn together. So what keeps electrons in their orbits, and how do they escape to create electricity? It's a balance of forces. As the electron orbits, centrifugal force tries to pull it away, much like swinging a ball on a string. This is perfectly balanced by the positive attraction from the nucleus pulling it inward. However, if we apply a strong enough outside force, like heat, friction, or chemical energy, we can help that centrifugal force overcome the nucleus's attraction. When that happens, the electron breaks free from its orbit. The movement of these freed electrons is what we call electricity. Electrons don't just orbit anywhere. They travel in specific paths called orbital shells. An atom can have up to 7 shells. The electrons closest to the nucleus are held very tightly by that positive charge. The further away a shell is, the weaker the attraction, making those outer electrons easier to free. The very outermost shell of any atom is called the valence shell, and the electrons in it are valence electrons. This shell is crucial because it can never hold more than 8 electrons, and these are the electrons that are most easily set free to create electrical current. The number of valence electrons an atom has determines how well it conducts electricity. We categorize materials into 3 main types based on this: conductors, insulators, and semiconductors. Let's look at how the number of outer electrons defines these categories. Conductors, like silver and copper, typically have only 1 or 2 valence electrons. Because any energy applied to the atom is concentrated on just 1 or 2 electrons, they are very easy to knock loose. This makes them excellent for carrying electrical current. Insulators, on the other hand, have 5 or more valence electrons, with 8 being the most stable. When energy is applied, it has to be shared among many electrons, so none of them get enough energy to break free easily. Materials like glass or rubber hold on to their electrons tightly, preventing current flow. To wrap up, remember that electricity is all about the movement of negative electrons. The structure of an atom, specifically the number of electrons in its outermost valence shell, dictates whether a material will easily give up electrons to act as a conductor or hold on to them tightly to act as an insulator. Understanding these atomic principles is the key to understanding how electrical systems work.